Okay. Last time we talked about gap acceptance. Okay. So what is a gap? If you are coming from the minor highway or the minor approach, the headway between the vehicles on the major approach is the gap. Okay. And we talked about gap acceptance. Okay. That as a driver you decide whether this headway is enough or not, and then you decide whether you should enter between that headway or not. Okay, so that is your gap acceptance. Then we talked about critical gap. Critical gap is which one?
The gap which 50% of the drivers accepted and
Yeah. Okay, the gap which has 50% acceptance and 50% rejection. I showed you the curves, the intersection point of the curve. You can plot the curve accurately, do it from the curve. If not, we have an equation. Okay. Then we started talking about the types of analysis we do, or the types of approaches we have for traffic analysis. One of them, which we have been doing up till now, okay, was deterministic, meaning everything has one exact value and there is no other chance of any other value. Okay, which we know that it's not real. Okay, it's not real. There are, I don't know, 18 students in the class. How many are there now? 9. Okay, but there is a chance that there could be 10 as well, right? Okay, so this is called as, say it. Stochastic. Okay, in our days there used to be oral exams as well. You guys don't have this, right? Huh? In the schools? You do it? You do it? Okay. Okay. So then you are worried about how to say this word and so on. Okay. Anyways, so the stochastic approach says that there are other possible values. So the importance is not for the value. Importance is the chance of that value. Okay. The chance of that value, the probability of that value. Okay, so we are not looking for the exact value, we are looking for the value which has more chance. Okay, and how to calculate that chance or probability? We have to assume that the traffic flow follows a distribution which we already know. Okay, and we already know Poisson. Okay, the thing which you feel like eating now. Okay, so we know Poisson distribution is you don't know it, but other people know it. Okay, so they know how to find out the probability of flow when it follows Poisson distribution, which is given by P of x. Okay, in this equation, then what do we need? We came to, there was mu, and we said mu equals to lambda into t. What is lambda? The total flow upon total time. What is t? The time of your observation. So you can replace mu with lambda into t. Okay, and this is the equation then, where you are looking to find out probability of x. What is x? Number of cars you can have, number of vehicles, flow. Number of vehicles in how much time? Time small t. Got it? Okay. So this is the equation. Then we said if you make the time interval small t less than the headway between the vehicles. So the headway is 3 seconds. You are only looking at the road for 1 second. Okay. Then how many vehicles you can have? You will have 0. So if we put x equals to 0 here, then the equation is this. Okay, wherever you put x equal to 0, it will cancel out and become 1 and so on. Okay, so the simplified equation when x equals to 0 is this. When the x can be 0, when your observation time is less and vehicles are taking more time. Okay, headway is more. And if the chance of 0 is this much, then the chance of not having 0 is 1. Okay. So we call them what? These two are called as what? There's a term for that. These two are what? Hmm? Yes. These two are called as what? So you see, he is 10 minutes early, he is 10 minutes late. What do you call them? Huh? What?
Assalamualaikum.
Why this one? Yeah. Opposite, okay? Okay. For me, complementary, okay? Yes, they are opposite, obviously. But we call them complementary, okay? Something which will make it whole, okay? If you add both of them together, it will be equal to 1, okay? So, this is where we have reached last time. Moving on. Okay. Let's say you have observed for 1 hour. You observed for 1 hour and you counted 360 cars. Vehicles. 360 vehicles. Okay. So you took observation for 1 hour and you counted 360 vehicles. Assuming the arrival of the vehicle, the flow of the car is following Poisson distribution. Estimate the probability that you can have 0 cars in 20 seconds, 1 car in 20 seconds, 2 cars in 20 seconds, and so on. Clear? Clear? We have to find out probability, P. This way. Okay? And what is my X? The number of cars they are asking me. Okay? So, let me take this. Okay, so I want X. I'm calculating the probability for X to be 0, 1, 2, 3, 4, and 5 or more. Okay, this is together 5 or more. Okay, so this is exact 0, exact 1, exact 2, exact 3, exact 4, and then 5 or more. Anything 5 or more. Clear? Clear? How many probabilities I need? 1, 2, 3, 4, 5, 6. 6 values of probabilities. Clear? Okay. I also need a small t here. Okay. Now, they are asking for probability of these values in how many seconds? 20 seconds. Okay. So, my small t is how much? 20 seconds. Okay. And then we have lambda here as well. Okay. Lambda was total volume upon total time. Total volume upon total time. Look at the question. Where did they give me total volume?
360.
Yeah. So total volume is 360 and total time is 1 hour. Okay. So should I do 360 upon 1? Then what? Convert it to seconds. Why? Why convert to seconds? Why?
Too much,
What too much? Nothing is too much.
Small t.
Yes. Okay. There is no conversion in the final equation. So if the final equation you are going to put small t in seconds, then lambda should be per second as well. Okay. But if they ask you what is the probability of cars in 0.5 hours, so they are already saying 0.5. Keep it in hour, no problem. Put 360. Okay. So we are just doing it for the sake of units. Okay. We are just doing it for the sake of units. Small t is in seconds. Good. Convert lambda into per second as well. Clear? It has nothing to do too much or too less. Okay? Clear? So it's just for the sake of conversion. Okay. How much is this? 0.1. Okay. Then the p values. Tell me. So P of 0 will be, we put x as 0. How much is it? You will do it. Yes.
You wrote 9.1.
9.1. Ah. Yes. P of 1 is how much?
0.27.
Okay. So now pay attention. These values are given here. Okay. And this is how it is calculated. Clear? Okay. Anybody has any problem up till now? Any problem? Okay. So you put here 0, 0, you will get P of 0. You put here 1, 1, you will get P of 1. Okay. 2, 2, P of, okay. Everything else is constant. Okay. Any problem up till now? It's clear. You want to check the values? These are the values. Okay. Now the only thing here is, the only trick here is the last one. Okay. What do I do for the last one? The last one is different.
Find the summation, one minus the summation.
Yes. The last one is different because they are not asking for 5. They are asking for 5 and above. Okay. Meaning what? 5 and above means what? Anything which is not up to 4, right? Anything which is not up to 4. Okay. So what we will do, we'll find the probability from 0 to 4. Okay. So we'll add all these values. So P 0 to 4 and you add all these values. So how much is that? Okay, up to here, up to 4. How much is that?
Nine, four, seven. 1947.
947. Okay. So if you want the probability of, how should we write it? X okay. So from 0 to 4 is 0.947 and whatever is remaining is 5 and more. Okay, got it? Okay. So it is 1 minus 0.947 and you should be getting the number.
053.
Okay, clear? Any questions? Okay, so you have to always keep in mind that the equation gives you a value which is for an exact value of x, gives you a probability which is for the exact value of x. Okay? Okay, consider the same situation, 360 vehicles per hour. Again, assume the vehicles are following Poisson distribution. What is the headway? What is the probability that the headway between successive vehicles will be less than 8 seconds? And what is the probability that the headway between successive vehicles will be between 8 and 10 seconds? Okay. But find what? No. See, now the equation, this equation is to find out the probability of number of vehicles. They are not asking for probability of vehicles. They are asking for probability of headway. They're asking for property of what? Headway. Okay. So they are saying, what is the probability? What was the question? Read it. Yes. Father.
What is the probability that 6 or more vehicles will arrive in each of the next least 60
Kill
seconds?
him. I have nothing. Which question are you?
This or
This one. Yeah. What's the question?
what is the probability that headway between successive vehicles will be between 8 and 10 seconds?
Before that.
So, what is the probability that headway between successive vehicles will be less than 8 seconds?
Less than 8 seconds. So, which are we talking about? This condition or this condition? Okay. Headway less than how much?
8 seconds.
8 seconds. Okay. So now I will directly use this. Okay. You cannot use this equation. This equation gives you the probability for x. Okay. Are they asking for probability of x number of vehicles? No. They're asking the probability that the headway is this or that. Clear? Clear? Okay. So give me the probability that the headway is less than 8 seconds. So your lambda and everything is the same, right? Okay. What do we need here? Lambda, right? How much was lambda? 0.1. So lambda is 0.1. I am finding out the probability for h to be less than 8. Okay, and this equation, so t will be 8.
0.45.
Okay, so what is the probability that the headway between two vehicles will be less than 8 seconds? 55%. Any two vehicles in this hour. Okay, so if you keep on looking at the vehicles and they're noting down their headway, there's 55% chance, or if you do it for 100 times, 55 times you will find a value which is less than 8 seconds. Clear? Clear? Okay. What is the next part of the question?
The probability that headway between successive vehicles will be between 8 and 10 seconds.
Between 8 and 10, meaning now you already have less than 8, right? Okay. If you do it less than 10,
So include it. We will do it for more than 10.
more than 10, yes. Okay. So how much is the probability for headway to be more than 10? Okay. Find out the probability for the headway to be more than 10. So P headway
37.
Okay. Less than 8, 55% chance. More than 10, 37% chance. Whatever is remaining is between them. Got it? Okay. So it will be 1 minus these things. So
8%.
yeah, just let me write it. So we have 8, then headway, and then we have one minus how much?
0.08.
8% chance. If you record 100 values, there will be 8 values between this range. Clear? Okay. Any problem? Okay, so keep one thing in mind that whenever we have this sort of a situation, we always use equal to sign with one of the values. Okay, it's a common practice. Okay, so you can see here equal to sign is with 10 only. This is for convenience because this equation is already equal to an mole. Okay. If I try to make this equal to an less, then I have to do something with the equation, right? I don't want to change the equation. Convenient thing is between 8 to 10, the equal to sign will go where? Because already there. Because it is already there. Clear? Any problem? Okay. Now, traffic data are collected in 60 seconds interval. This is the data. Okay, this is the data they are talking. For how many minutes it is collected? How many minutes you see it?
60.
How many minutes?
1 minute.
How many? How many? One value is 1 minute, I know that. I will not ask you how many.
15.
15 minutes, right? Okay. 15 minutes. Each value is for 1 minute, but they did for how many minutes? 15. Okay. Assuming the traffic arrivals follows Poisson distribution, and it will continue in the same rate after these 15 minutes as well. It will continue with Poisson distribution. What is the probability that 6 or more vehicles will arrive in each of the next 3 60-second intervals? Okay. So we'll use the same thing which we used earlier. Okay, we will use the same equation, this equation, right? Okay, so what do I need? I need lambda, and I need lambda. How do I get lambda? Lambda was what?
Summation.
Volume over time. Okay. Volume, which volume? The total, right? Okay. So you have to do the summation of the given value. What is that? How much is that? Divide by 15. Should I convert it to seconds or hours or something? Should I convert? Last example I converted, right? 2 seconds. Should I convert here?
Because
No,
the
why not?
previous question that between the volume backup per hour and t in second.
T seconds. Here T is what?
1
60 seconds. This is already 1 more. So it's fine. Okay, clear? Clear? Okay. So this is why I said we don't convert because it's too small or too big. We are doing it for the conversion. How much is this?
6.733.
Okay, now they are asking me what is the probability that 6 or more vehicles will arrive. 6 or more. Okay. So again, it's not a fixed number. They are not asking for probability of 6. They are saying 6 or more. So what did we do in the previous example? It was 5 or more, right? We're calculating the probability of 5 or more. How did we get this number? Huh? Yes. Okay. So it was 5 or more. So we calculate the probability from 0 up to 4, and then we subtract it from 1. Okay. The probability of 0 to 4 is 0.947, and whatever is remaining is more than 4, right? So 5 or more. So here we will do the same thing. Okay. So probability of, we want probability of 6 or more. Then we have to find out the probability for 0, 1, 2, 3, 4, 5, and then subtract it by 1. Okay. to use this equation up to 5 and then add all the values, subtract from 1. One minus all the values. 1.
One six six four.
After 1 minus. Oh my God.
Workshops.
If there's a difference like this in the exam, I will take his value. Okay? And your value doesn't match, your grade will be low. It takes him more effort, you see. Right or wrong? Okay, anybody has any problem with the question? Okay, is it clear? What we have done is clear? Okay. This probability 0.664 is the probability that the number of cars in any 1 minute interval, is 6 or more in any 1 minute interval. And it could be 12:14 to 12:15. It could be 12:15 to 12:16. It could be 12:16 to any 1 minute. Okay. But what they are asking for is something else. They are saying what is the probability that in 360 seconds interval you will have 6 or more cars. So they are not asking for one interval. They are asking for 3 intervals. Okay, 3 intervals, one after each other, one after the other. Okay, so if you tell me this is the probability of having 6 or more cars, this is in one interval. That interval could be anywhere. Okay, but what is the probability that even the next one will have 6 or more cars? Now, yes, multiply what? No. 0.6 multiplied by 3 will be how much? 1.8. Okay, and if your probability goes more than 1, your grade goes to 0. See? There's something which they call as peer review. Like I take the assignment from him and give it to him, take it from him, give it to her, and you grade each other. Huh? We should do this, right?
Exam.
Huh?
Exam,
Yeah. By the time you will come, everything will be checked. Okay? So no use for you, right? Okay. But my point was what? Yeah. To have 6 or more cars in 2 consecutive intervals, 2 consecutive minutes. To happen it for the second time, the first time should have happened already, right? I'm looking for 2 consecutive, right? Okay. So it's like I say there will be 2 cars with the same color going after each other. So it cannot happen if for example, the second car is black. To fulfill my condition, the first one should also have been same color, right? Okay. So to have the first one black, and then the second one black, and then the third one black, the chances will become more or less? Less, right? Okay. So what do we do if we have such situation? Then we don't multiply by 3. We take the product. We take the product. Multiply the probability with each other. So if you have 6 or more cars 3 times, I'll take the cube of this probability. It will be to the power. That number of times will go to the power. Okay? So will this number will become more or less? Less. Why it is less? Because for the second time to happen, the first time should have already happened. And the first time only has a probability of how much? 6. If you say the probability of having this is 1, okay, then yes, first time it will be, okay, this number of cars, second time it will be this number of cars, third time it will be this number of cars. There is no problem there, okay, because the probability is 1, full probability, no chance of having any other value. Okay, then it's easier, then no problem. Okay, you will say just yes, it is 100%, no problem, don't do anything. But second time for this to happen twice, the probability is less. For this to happen 3 times, the probability is even less. Okay, why? Because for the second time to happen, the first time should have already happened, and the first time has the probability of this much. Okay. So when you take the cube, and this is how they show it. This is a way of showing it. Okay. So whenever you see this symbol, that means you are multiplying. So I am multiplying what? How many times? 3 times. Clear? So how much is that?
29.293.
Come on. Okay, did you get this? Did you get it? Any problems? So to have probability of having 6 or more cars in any minute is 66%. For this to happen 3 consecutive times, it is only 29%. Okay, we multiply. Clear? Clear? Okay, now let me change the question. What is the probability? What is the probability that in the first minute you will have 6 or more cars? Tell me how much. What is the probability that in the first minute I will have 6 or more cars? How much is that? 0.6, right? And what is the probability that in the first minute I will have 6 or more cars? and the next minute I will have 5 cars. 6 or more in the first minute, 5 in the second.
This one times this one.
Multiply by probability.
This one times this one.
Multiply by probability of 5.
Yeah. So this multiply by the probability of 5. Okay? Yes. He said this one, this one.
Everything I said, everything he said is wrong.
Okay. Clear? When people say this and that, I have to be careful. I have to explain. Okay. I cannot leave it up to you. Because there can be this and that in the exam as well. Huh? I see the paper, the arrow is going there and arrow is going there.
بس you have to know it يعني انت في الإكزام اوكي وبتعرفها.
Huh? I know, but you don't know. Okay, clear? Okay, get the idea what we are doing. So whenever we have consecutive probabilities, we multiply. We multiply. If it is the same number, consecutive times, obviously you will take the power. But if there are different numbers, then you multiply with different probabilities. Okay, clear? Okay. Yeah. We talked about gap, right? Gap. What is the gap? See? What is the gap?
يعني كم بتعرف
Yeah.
to the road there's some vehicle coming. The gambit.
Yes. Okay.
Did it?
Did you give him any money for this? You say one more time, I will kick you out of the class. Okay. Now, if I put, for example, if I put, let's say, 3 lines on the board, how many gaps are there between the lines? 2. Okay. If there are 3 lines, the number of gaps is
2.
If there are 4 lines, number of gaps is 3, right? Clear? So let's say these lines are the cars. Okay. So if you have 4 cars, then you can have 3 gaps between them, right? If you have 5 cars, then 4 gaps between them, right? So if V is number of cars or number of vehicles, then number of gaps is
Why?
why? Why? Okay, this is understood. Okay, so if we have V number of vehicles, then we have V minus 1 number of gaps. Okay. Now if the gap which we are looking for, gap is the headway, right? Gap is the headway. So we already have this equation. This is not the equation. This is for frequency, yes. So we have an equation. We used it here. This one. Okay. This equation tells you what? Probability that the headway is more than my time of observation, right? Probability that my headway is more than my time of observation. Okay. So if this is the gap, if I make this as the gap, okay, and this is my acceptable gap, okay, so what is the probability that the headway between the vehicles is more or equal to my acceptable gap? If it is more, will I cross or not? Yes, right. I will cross. Okay. So for example, this thing, so vehicles are coming at different gaps, right? They're coming at different headways. If this situation happened 10 times, this situation happened 10 times, then how many people will enter? 10. Okay. How many people will enter? 10. Now what is the percentage of this situation happening? This, right? P is the value that this can happen how many times? Percentage. what percentage of times this can happen. Okay, percentage out of total, right? How many total gaps you have?
V minus 1.
V minus 1. Okay, so this is the probability of having one gap. This is the probability of having one gap. Okay, so in total of V minus 1 gaps, how many times this can happen? This into V minus 1. Okay, so this is what they are saying here. This is what the probability of one gap. And this is total. Okay, total number of gaps here. Okay, so probability multiplied by total number of gaps, you have the number of acceptable gaps in your flow. Got it? Okay, and obviously if this is for this, then for the reverse is 1 minus. So if this is the probability for acceptable gaps, this is the probability for not acceptable gaps. Okay, and this is the number of times it can happen. When you multiply by V minus 1, it becomes frequency. If you don't multiply, it is percentage, probability, chance. Clear? Okay, so we already know about this one. We multiply this with a total number. We know in total how many times it will happen. Clear? Okay. Any question? Okay. The peak hour on volume, the peak hour volume on an expressway merging area is 1,800. Okay, it's a merging area, so that means a ramp is coming. A ramp will come and merge. So in this area, the expressway, the main highway has flow of 1,800. Arrival follows Poisson distribution. Critical gap 3.5 seconds. Critical gap is 3.5 seconds. So we are looking for a gap of 3.5 seconds. Determine the number of acceptable gaps. Okay, for the ramp vehicles that will occur in this hour. The hour which has how much volume? 1,008. So when the volume is this much, for the people who are coming from the ramp, how many gaps they will find of 3.5 seconds or more? If they find 3.5 seconds, it is critical, means acceptable. Okay, so how many times they can find this? Okay, so we have this here, so we are going to use this one, the first one. Okay, tell me the values. Which values do I need? Which values do I need? I need V, I need lambda, I need T. T is 3.5. We are looking for H to be more or equal to 3.5, right? The gap, the critical gap. Okay, so
1,800 over 3,600.
How much? 0.5. Okay, V.
1,800.
1,800. Okay, so what is the frequency now? I call it F
312.
H how much?
312.
Okay, now it means what? 312 times in this hour the vehicles will find a gap which is equal to their critical value. 312 times. Okay, so when they will find this much gap, what they will do? They will
Cross.
Cross. So how many people can cross from the ramp?
312.
12. So this gives you the allowed flow from the ramp in this hour. It's a peak hour, obviously. Okay. When this flow will go less, okay, there could be more vehicles who can enter, okay, because they will find more gaps then. This is what they have done, okay, so they prepared an entire table with all the values, okay, 3.5 is here, our number is correct, okay, so here are the probabilities and here are the numbers, okay, to have a gap of 0, the probability is 0 or more, obviously, 0 is the minimum value, right, so all values are more than 0, probability is 1, and 1 multiplied by b minus 1, 1790, okay, and so on. And they, for us, they have calculated the other probability as well. So there were total 799 gaps out of 799. If these are 312, then the rest is the other one, the not acceptable one. Okay, 312 are the acceptable ones, and 1400 something is the not acceptable one. Okay, now the last thing in this topic is the value of a minimum headway. Okay, usually there is a headway which does not exist. There is the value of the headway which does not exist. We call it the minimum headway. What is that? Which the drivers do not accept in any condition. So that value in your data will never exist. Okay, for example, a value of 0 means what?
Nothing.
Huh?
There is no gap.
There is no gap. Means what? You did what? An accident. Okay. And even up to 1.5, this is considered very, very close. Okay. So these values will never exist. So we can modify the equation to replace the because if you say there is a probability of 0, you are lying, right? There is no probability that the headway can be 0. And if you say the acceptable headway is even never less, even never is, it is never 1 as well, then you are lying. Okay, so the probability of 0 does not exist. Probability of 1 does not exist. So they should be taken out of the equation now. So how do we take them out? It was minus lambda into t. So instead of doing minus lambda into t, we will do t minus minimum head. Okay, we are calling it tau. What is tau? Minimum head. Got it? And that also means what? T can never be
0.
never be 0, but it can never be equal to what? T can never be equal to what? Or should never be equal to what? The minimum. Okay? It should never be equal to this or less than this. T should always be more than this. Clear? Clear? Okay. So if you do this, okay, then how many gaps you will have in the previous example? It was 799 into this thing, right? So how many gaps you will have if you put here lambda into t minus tau? Let's say tau is how many? 1 second. 1 second. Okay. So t was how much? 3.5. So instead of taking the power 3.5, you will take 3.5 minus 1. Okay. Multiply by lambda. How much is this?
5.5.
How much?
5.5.
514. Did it increase or decrease? Increase. Because the equation was considering that there is a chance of 0 as well. The total of probability is how much? Total probability is how much? 1, right? So out of 1, it was giving something to 0 as well. Then it was giving something to 1 as well. Those two don't exist. So the probability or the chance of the remaining values will increase. Okay. So now you will not say 312 vehicles will enter from the ramp. How many can enter? 500. Okay. Any questions?
515.
525?
515.
515? Oh my God. That was your car, right? One car, that was yours.